Good day, Earth Science students. Welcome to video lecture episode 11. Today we're going to fully dive into, or at least get started, on chapter 23, and that is the Sun, Earth, Moon system, and this is within Unit 7 dealing with astronomy. Now the big idea for this unit, and which is contained even in this chapter, is how are thunderstorms and neutron stars connected? Now let's look at the main ideas. I know we briefly mentioned this on Friday, but I do want to just go into this a little bit more and just review, just in case maybe some of you hadn't seen or had forgotten. So the main ideas we're going to be talking about Earth. We're going to talk about the properties of Earth, what causes changing seasons, solstices, as well as equinox. Now let's consider the three objectives for this first section of chapter 23. This is on slide 5 and 6. Okay, objective number 1 is examine Earth's physical characteristics. Objective 2, differentiate between rotation and revolution. And thirdly, discuss what causes seasons. So let's first go ahead and get into the properties of Earth, and let's just talk about something that we're all very familiar with. Well, we waken at daybreak to catch the sun rising from the dark horizon. Then it begins its daily journey from east across the sky to the west. Finally, the sun sinks out of view as night falls. So the question I ask you right now, just think about this. Is the sun moving, or are you moving? Think about that. Now, keep in mind, it wasn't long ago that people actually thought that the Earth was at the center of the universe. It was actually widely believed that the sun revolved around Earth, which stood still, and this model was called the Geocentric Model, and that geo referring to Earth, and then centric, obviously center, and then model. Okay? Now, it is now common knowledge that the sun only appears to be moving around the Earth. In other words, people know that the Earth is actually moving, not the sun. Now, because Earth spins as it revolves around the sun, it creates the illusion that the sun is moving across the sky. In other words, not only is the Earth going around the sun, but then the Earth itself is spinning internally, and that's it appears that the sun is moving when actually it's us, the Earth, that is moving. Now, another mistaken idea about Earth concerned its shape. Even as recently as the days of Christopher Columbus, many people actually believed on the Earth that the Earth was flat. Alright? Now, because of this, they were afraid that if they sailed far enough out to sea, they would fall off the edge of the world. How do you know that this isn't true? How have scientists determined the shape, the true shape of the Earth? Just think about those questions as we consider. So let's talk about the spherical shape of the Earth. A round, three-dimensional object is called a sphere. Its surface is the same distance from its center at all points. Now, some common examples of spheres that you should be familiar with are basketballs and tennis balls are two good examples. In fact, if you look on to slide 12, I have some images of both a tennis ball, some tennis balls, and a basketball in comparison to the Earth, which is spherical as well. Now let's move to slide 13. Let's talk a little bit more about the spherical shape and its development. In the late 20th century, artificial satellites and space probes sent back pictures showing that Earth is spherical. Much earlier than this, though, Aristotle, a Greek astronomer and philosopher who lived around 350 BC, suspected that Earth was spherical. Amazing, that even that far back. Now, referring to Aristotle, he observed that Earth cast a curved shadow on the moon during an eclipse. In addition to Aristotle, other individuals made observations that indicated Earth's spherical shape. And we're going to close off today at slide number 15. In fact, let's just consider some example here. Early sailors, for example, noticed that approaching ships came into view a little at a time, as shown in figure 1. Now, I do not have that particular image, but I have a similar image posted on slide 15 just showing a Navy ship and just an example of a ship approaching. I do hope this has been helpful. If you have any questions, please leave those in the comments below, and I look forward to reading your comments and interacting with you in lectures. Take care. Goodbye.